10 randomly selected people were asked how long they slept at night. The mean time was 7.1 hours, and the standard deviation was 0.78 hours. Find the 95% confidence interval of the mean time. Assume that variable is normally distributed. All right, so they told me that it's normally distributed because we don't have a sample size that's greater than 30. They either have to tell me one or the other, that I have a sample size greater than 30 or that it's normally distributed. But, so that part's good. I still want to go through and I want to see what I can identify. So they took a sample of 10 people and the mean time was 7.1 hours. So what variable is that? That's my x bar. What is my n? And 0.78 is what? Now, what standard deviation is it? It's of the sample, so it's my S. So 0.78 is my sample standard deviation. And notice, they didn't end the sentence and say the population standard deviation is, like they did in the last packet we were looking at. They would end the sentence about the sample and then tell you the population standard deviation. If you don't have that, you probably have the sample standard deviation. And that's how you're going to kind of distinguish these two as we go on, because these distributions are really similar. So we have to figure out which standard deviation they gave us. So they did not stop the sentence and tell me your population standard deviation is. They didn't tell me anything about a population. So all I have is sample information. And the last thing is we have a confidence level of 0.95, which means that my alpha is 0.05. All right, so I need to find my critical value. So what's my degrees of freedom? 10 minus 1, so I've got 9 degrees of freedom. So I'm going to use my 9 and my 0.05 on the table, or you have to divide it by 2 if you're going to use your calculator. So I'm going to go back to the table. I'm in the 9 degrees of freedom row and 0.05 in 2 tails. So that puts me at the 2.262. Your calculator is probably going to give you negative 2.62. So my T alpha divided by 2 is 2.262, which is good because I need that for this interval. Now that I know what the T alpha is, I want to build my margin of error. And my margin of error should be 2.262 because it's T alpha times your standard deviation, 0.78, and you want to divide by the square root of n. So the square root of 10. Yes. Yeah, we're going to fill in the pieces that we need. Yes, for intervals. What is that going to give me? .55? And you said 8?
0.5579.
All right. So we'll do 0.56. That'll be good. All right, so I've got my margin of error, and then just like before with the z, we're going to do x bar minus your margin of error and x bar plus your margin of error. So 7.1 minus 0.56 and 7.1 plus 0.56. What is that going to give me? Yes. Seven 7.1 minus the 5 or 0.56 is 5.4. And what if we add it? we're going to get 7.66. So, what can I say about those two numbers in a sentence? We are 95% confident that the mean number of hours a person sleeps is between 6.54 and 7.66 hours. And again, this is the mean of the population. We used this sample to try to tell us something about the population, not just our sample here. Questions on the by hand process? Yes. The Z in a calculator, we can probably do a T in a calculator. So since it is a T distribution, we're going to do a T interval, not a Z. So we'll go back to the stats area and test and go find your intervals. And underneath the Z interval is your T interval. Again, we have stats because it summarized all the information for me. So I can tell it that X bar was 7.1. T interval. You're building an interval. And then my S is 0.78. N is 10. And we want to be 95% confident. So 0.95. Did everybody find it? Does everybody look like mine? All right. And we're going to get a really similar interval. So 6.542. And 7.658. Data represents the sample of the number of home fires started by candles for the past 7 years. Data are from the National Fire Protection Association. Find the 99% confidence interval for the mean number of home fires started by candles each year. All right, so what can I identify? Confidence level is 0.99. Is it? Do we have an X bar? We have data, but we don't have an X bar. So we can find the mean. We know how to find the mean of data. Or we could put in a list and tell our calculator we have data. Either way. So I can put it in a list and find the mean and standard deviation and do it that way. I can use the formulas to find the mean and standard deviation, or we can just use the calculator altogether. So whichever way we want to go, let's go ahead and start with putting this in a list. Except I covered up my data, so that doesn't help. 5,460 stats, and then edit. I'm putting in all the data points. And make sure you put them all in correctly, because I definitely put one of them in incorrectly. All right, so once I have the data in the list, like I said, if you decide you want to do it by hand, you could find the mean and standard deviation and go that route. Or it's already in there for me. So I'm going to go to my stats and over to my test, and find my t-interval, because it's still based on a sample. I don't have anything about a population in there. And this is the time I want to choose data, so that it tells me that there's a slot to give it a list. It asks you what list this is in. I'm going to tell it that it's in list 1. Your frequency should stay 1. We don't have a frequency list for this, so don't put anything other than a 1 in there. And then how confident you want to be. 0.99. Does everyone find this? And then let's calculate. It may take it a minute to think about it. Yes? How do you get from the list to the, so it just hit stats again? And then arrow over to the testing side. Does everyone agree with my interval? 1. Just 1. Because each number we put in once, and that's when it's just going to happen. Notice that this gives you your mean and your standard deviation. So it gives you the same mean and standard deviation that one var stats would give you. So you can get your summarized information and kind of roll on with the formula if you want as well. It doesn't really matter what you want to do. This is going to save you some time. Yes? Did anyone else get a different interval? No. I would check the data. So we should have 7 pieces of data in there. And then make sure there's no extras in there. Did you put a frequency in as 1? In here? Body temperatures of men and women. The results are shown in the table. Assume that the 2 samples are independent samples selected from a normal distribution population, and do not assume the population standard deviations are equal. Find a 98% confidence interval for the difference in the means. All right. They've already summarized everything for me. All I need to say is that the confidence level is 0.98. And then, since it's already summarized, I could go ahead and use my 2 sample t-int, and it's going to take everything that I've got. So let's see what we can put in here. We're going to go to our stats and testing area. Find our 2 sample t. The mean of the first one is 97.57. Standard deviation is 0.84. And n is 11. X bar 2 is 97.46. S is 0.65. And n is 59. And we want to be 98% confident. So we want to put in a 0.98. And make sure you leave pooled as no. You don't want to change that portion of it at all. Did anyone get that sort? Sea level is 0.98.
No, I don't have it on here.
Did you go to the test?
Yeah.
You want to go to the interval.
Okay.
2 sample interval. Otherwise it's going to ask you for other information. So keep going past the Z interval and you'll find it. All right, let's see what it gives us. So we're going to get a negative 0.63 and a positive 0.823. Did everyone get the same thing? What would you tell me about that? We are 98% confident that